through solving simple radical equations. And it is really a three-step process with an extra step at the end. So the first thing you would like to do is make sure that the radical has been isolated. So make sure that you've isolated the radical, and then you square both sides of the equation, and that eliminates the radical. It's the inverse of the square root by squaring. Then you solve the equation that remains, and then the new thought is checking for what are called extraneous or extra roots. And extraneous roots are simply solutions at the end that make the original equation false. And then remember that if you have the square root of x times the square root of x, that's the same thing as x times x underneath the same radical, and that simplifies as x to the first. So in these equations, we're solving for x to the first, and the problems are presented with the variable underneath the radical. So we need to have a way to get to the variable when it's underneath the radical so that we can solve for its value. So let's do a few examples together. So number one, very basic, simple problem. I have the square root of x equaling 9. So I'm trying to solve for the x, but the x is underneath the radical. So the way that I'm going to inverse it or get to it is by squaring both sides. So now I end up with x equaling 81. And then to check that answer, the square root of 81 equaling 9, that's a check, so that works. Let's look at number 2. So number 2, I have a little binomial n plus 5 underneath the radical. So when I square both sides, I simply get n plus 5 without the radical, but I set that equal to 2 times 2 or 4, and then solve this for m, and then do your check. Here's your check. Is negative 1 plus 5 equal to 2? And that's the same thing as the square root of 4 equaling 2. So that checks. M equaling negative 1 is a solution that works. Looking at number 6. Squaring both sides, or number 3 rather, squaring both sides. 6 times 6 is 36. And then squaring 4y underneath the radical, you simply get 4y. And then dividing both sides by 4, multiplying by 1/4, 9 equals y. And then to do your check, does 6 equal 9 times 4? And 6 is the square root of 36, so that checks. Let's look at number 4 on the screen. So here, the radical has been isolated. When I square both sides, I end up with, and I'll change the a to an x, whoops, I end up with x over 3 being set equal to 49. Don't forget to square the other side. And then multiply both sides by 3 over 1 to isolate the x. And then you get the value x equaling 147. And then to check this, 147 divided by 3, does that equal 7? That's 49. Square root of 49 is 7, so that checks. Let's move on and look at, let's go to the other side. Let's look at a problem like number 8. Number 7 and number 8. So in a problem like number 7, notice that it's just simply radical x minus 7. The minus 7 is not underneath the radical. So the first thing you need to do is isolate the radical. So adding 7 to both sides, and you have radical x equaling positive 1, and then you square both sides, x equaling 1, and then you check your answer. Does the square root of 1 take away 7 equal negative 6? So the square root of 1 is just 1. So that's a true statement, so that solution checks. Let's look at number 8 and 9, and then I'll stop the video. Number 8, you need to isolate the radical first. So that means you need to divide both sides by -10. So then you have positive 5 equaling radical n, and then you square both sides. So 25 equaling n, and then to check, you've got -50. Does that equal -10 times the square root of 25? So -50 does equal -10 times positive 5. So that answer checks. Let's do number 9. So the first thing you need to do is isolate the variable. Or excuse me, isolate the radical. So subtracting 1 from both sides. Then you have the negative x plus 2. This would be 1. Set equal to 3. And then I would divide the negative. Think of dividing both sides by -1 to eliminate the negative sign. And then you have x plus 2, and that's set equal to -3. So if I square this, I'm going to get x plus 2 equaling 9. And then if I subtract 2 from both sides, x equals 7. If I put this back in for checking, here's my original equation. 1 minus x is 7. So this is going to be 1 minus the square root of 9 equaling 4. And 1 minus 3 does not equal 4. So this is an example of what you would call an extraneous root. And I would say that this equation has no solution. This equation has no solution. So I'm going to leave this on the screen for a minute, and then I'm going to go back and I'm going to show you a way to arrive at that conclusion a little bit faster. But I wanted to show you what it looks like to check an answer that makes the original equation false. So let me erase all of this. Let's do some basic analysis. When I isolate the radical by subtracting 1 first, and then if I divide out the negative sign so that the radical is completely isolated with something positive in front of it, I have this scenario. I have a square root, a radical, with no operation in front of it, and it's equaling something negative. The only time we have that is if you had a question, something like this, negative sign in front, which tells you to take the root, but then make it negative. But that's not the case here. Here there's a positive in front of the radical. So when you have the radical set equal to a negative outcome, this is a no solution. This is a no solution problem. And I just went through all the steps to support that outcome. But when you've isolated the radical and it's set equal to a negative value, that is a no solution scenario.